Hello guys, today I'm explaining to you the most popular subject of all time called calculus. I know it might seem complicated because teachers, everyone fears it, but what if I told you it's not as complicated as you think? So first, there's three main topics we have to get through for introduction to calculus: limits, derivatives, and integrals. So first, guys, let's get what a limit is. So the definition of a limit is a, when the variable gets extremely close to a number without reaching it. For example, if we have 2x plus x to the power, oh wait, that's too complex. 2x plus 3, let's just do that. So the limit as x approaches 3, remember that. So limit is when x gets extremely close to a number without reaching it. So in this context, 2x plus 3, but x is getting very close to 3. But in this context, we could just plug in 3 and get the answer. So 2 times 3 plus 3, that's 6 plus 3, and that's 9. But this doesn't always work, because remember, limits is when a value gets very close to a number without reaching it. So let's get through another example. So x squared plus 1, limit as x approaches 5, we'll have 5 squared plus 1, or 26. But remember, this doesn't always work, because a limit is when a value gets very close to something without reaching it. Just making sure you remember. Now, let's get to the next topic, derivatives. Now, it isn't as complex as you think. A derivative, there's two ways you could write it: d divided by dx and f with an apostrophe of x. You might have heard of f of x before, but that isn't the same thing. That is not equal to f prime of x. F prime of x is a derivative and f of x is a curve. So, if we want to find the derivative, the definition for it is the instantaneous rate of change of a function. That might sound so confusing, but I'm explaining to you. So, if we have f prime of x equals x squared, that's just finding the derivative of x squared. So in blue, I labeled the curve, and as you guys actually don't know, there's a rule called the power rule, and it states the derivative of a power function, of a function with a power of x to the power of n, equals nx to the power of n minus 1. So in this context, we have x squared. So let's plug that in. We have x squared, derivative of x squared equals 2x to the power of 2 minus 1 over 1. So the derivative of x squared is just 2x. Remember, the derivative power rule formulas. Derivative of x to the power of n equals nx to the power of n minus 1. This isn't as hard as you think. So let's try another example. Let's say our curve right here was x cubed. Let's say it was x cubed. So the derivative is just 3x to the power of 3 minus 1, or 2. So 3x squared. And let's try with x to the 4. So x to the 4 is just 4x to the power of 4 minus 1. Or just 3 for 4x cubed. That's the derivative of x to the 4. Now this doesn't always work. Only works with functions with a power. Now, let's try an example with derivative by first principle to prove derivative of x squared equals 2x. So, you know the secant formula, right? It's y2 minus y1 divided by x2 minus x1. Well, in this context, y1 is just f of x, because that's a rule in calculus. The output is always f of x. And then we could label this distance right here h. And then, so this right here will be f of x plus h. This right here. So the formula for the derivative from first principles is f of x plus h minus f of x divided by h. Now, this is the formula. And we could actually do an example with this in derivative of x squared. So, f of x equals x squared, right? So, right now, instead we'll have x plus h squared minus x squared divided by h. So, x plus h squared, we could write that out as x plus h times x plus h times x plus h. And according to the FOIL rule, x plus h squared equals x squared plus xh plus another xh, or 2xh, and finally plus h squared. So instead, we have, I'm going to rewrite it on there. We have x squared plus 2xh plus 2xh plus h squared plus h squared minus x squared. Now, x squared and x squared cancel out on the top and just leaves us with 2xh plus h squared. We could factor out a h, so we actually just have 2xh. We just have 2xh. And finally, remember what I told you about derivatives. We're going to bring the limit as h approaches 0. As h gets very close to 0. And finally, we have 2x plus 0, or just 2x. Now that was very complex and difficult. I know. Now time to get to integrals. Now there's two definitions for integrals. We have indefinite integrals and definite integrals. So I'm going to explain to you exactly what they are. So first, remember how I said the derivative of x squared equals is 2x, right? So the integral of 2x. So think of integration as opposite of differentiation. So there's actually a rule for integration. So the power rule is x to the power of n plus 1 divided by n plus 1. So in this context, we have 2x. So we have 2x to the power of 1 plus 1, because there's imaginary exponent, or 2x squared divided by x plus 1 or 1 plus 1 or 2. And they cancel on the top. And this gives us x squared, our original derivative. So integration is reverse differentiation. Let's do another example with 3x squared, the integral of 3x squared. Remember, the rule is x to the power of n plus 1 divided by n plus 1. So in this context, we have 3x squared plus 1, or 3x cubed. 3x cubed divided by... Sorry guys, I just had to think. So remember, the rule was x to the power of n plus 1 divided by n plus 1. Well, we have 3x to the power of 2 plus 1, or just 3, or 3x cubed divided by 3. And the 3's cancel out and just gives us our original derivative, x cubed. So guys, now tell me in the comments, I have a trick question for you. What's the original derivative of... What's the integral of x to the 4th? It's not that tricky. Actually, let's go through this right now. So remember the rule. It was... Wait, no, it's actually 4x cubed. Let's find the original derivative. So, it was x to the power of n plus 1 divided by n plus 1. We have 4x cubed. So we have 4x to the power of 3 plus 1, or just 4. And then divided by 4. And they cancel out and give us x to the 4th, our original derivative. Now guys, I might have explained it confusing, but I hope you guys understand. And I hope this helped you a lot on your journey. See you next time, guys. Bye, guys.